Today's lesson is section 3.8, solving polynomial inequalities. Just so you are aware, there is no section 3.8 in the book. This is something that we added due to DMAC competencies, so that's why it's like an additional thing that I have also added to your notes. So if you wanted to look at those, these will be exactly the same as those notes. So if you wanted to pre-write those, that'd be great. So here, definition of a polynomial inequality of degree n in one variable is of the form just like it would be for polynomial equalities. So a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus dot dot dot, etc., all the way to plus a sub 1 times x to the first power plus a sub 0, which is less than 0. Okay? Remember, your leading coefficient is not equal to 0 here, and where all your coefficients are real numbers. Now, this equation up here at the top is just one example. You're not always going to have less than sign there. It could be other signs. So remember that polynomial inequalities may also include any of the other following relations. So greater than, less than or equal to, greater than or equal to. There will be two ways that we're going to show you how to solve these polynomial inequalities. So graphically and algebraically. So here, first one is to show it or to solve graphically. So here I have a step-by-step process of what we're going to do just so you know what to expect. Now, hopefully you notice most of the things we've already done when we were just solving polynomial equations. So really this isn't anything new to you. But for example, for step 1, it says make sure all your non-zero terms are on the same side of the inequality. We would have done that before. And for example 1a, it's already set up that way. Step 2 is we want to factor if we can. For all of these, I think we have made them so that you can factor them. So you're just going to use our normal tools that we've kind of worked on and practiced to help you get there. We want to be able to find all the zeros. Now, here I want to state what my zeros are. So remember, zeros are where the graph would cross the x-axis. So I'm not solving these. These are not solutions, because of that inequality there. So it's not really oh, I found my zeros, I'm done. I've got more to do after this. So I just want to state what they are. So x-intercepts would be, and you can write them like this if you want. So I would have a 3, it crosses at -5, and it crosses at -1. Remember, that's a double root, so that happens twice. Remember that I'm just taking them from the parentheses here, just like if I set them equal to 0 and solved. So that's all I'm taking them from. Now, once I found my zeros, the next step is to sketch a graph. Kind of like what we would if we were just sketching or just graphing them using our n behavior and our multiplicity. So I'm just going to make a sketch. There's my x, there's my y. So for 3, I'm right there. -1. So there's my -5, okay? Now looking at my n behavior, it looks like I have a power of 4. So I have 4 zeros, so that means my degree must be 4, right? So that means it's even. And then looking at my leading coefficient, because it would probably be -2x to the 4th, it looks like it's negative, right? Okay, so n behavior even negative, so that means both n's are going to be going to negative infinity. So if I graph this, so it's going to go through -5, and then because it's coming at -1 at a double root, let's fix that. That's going to touch and go. And then because 3 is just 1, it's going to go through. Now this is just a sketch, so My graph is probably not very good. Okay, now here, that would be the sketch of the graph. Remember, I'm not worried about how high these go, so don't worry about trying to find those. We don't need to worry about what our y-intercepts are here because we're just concerned with where, like what values for x make this inequality true. So looking at this, I would say that because it's greater than 0, that means that my answers need to be on the positive side of the x-axis. Okay, so looking at this graph, I would say this area is positive, right? Also, this area is positive. The rest are below the x-axis, so that means it's negative. So those aren't solutions or wouldn't make my inequality true. So when I'm writing this, I'm going to write my answers in interval notation. This is the solve part. So step 5. So I start being positive or above the x-axis after -5. So I would say parenthesis -5, comma, and it goes to -1. Okay. Now here, notice that I'm using parentheses. So at -5, -5 is 0, so on the x-axis, so that is not negative, nor is it positive, so I can't include it. Same with -1. I can't include it because it's not positive or negative, so I go with a parenthesis, then I do union, parenthesis, -1 to +3, parenthesis. So all those, because it was just greater than 0, I can't include those. If it was greater than or equal to 0, then I could use brackets to enclose those spaces because it would be also equal to for them. Okay, so let's try another one. I want to move. Okay, so if you would like to, maybe pause the video, try this one out for yourself using those 5 steps. But if you don't, I'm going to just continue solving this, but maybe a good time for you to practice here, just like we would in class. So here, I want to move all my stuff to the same side. It looks like the negative or the 6 is over on the right side. So I got to subtract. So it gives me x cubed minus x minus 6 less than or equal to 0. Now I need to factor. Well, it looks like this is not something that just straight up factors because it's not x squared minus x minus 6, so it doesn't work the same way. So here, I'm going to use my rational zero theorem. So I would say that my roots or possible roots would be 6, 2, 1 for the top, my constant, and then the bottom would be 1. So putting all those together gets me plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Okay, so those are my options. Maybe if I wanted to use the Cartesian rule of sines here to help me shorten my list a little bit. Here I would say that there's one change from the cube to the negative x, but then that's it. So there is one positive here. Because it's cubed, I would probably say, let's plug in negative x here. So I get negative x cubed. I get a positive x minus 6. So it looks like there, just 1. I get 1 here and I get 2 there, right? So there's 2, 0, 1, 0, 2. So it looks like at least I've got one possible positive solution here. So I'll try my or just doing synthetic division now. So 1, remember there's no x squared, so I have a 0 there, -1, it's -6. Okay, Since I had practiced this one before, I'm going to say that there is a 2. So 1 times, that gets me 2, add down, there's 2, multiply, that's 4, add down, that's 3, multiply, that gets me 6. So that is an answer. Okay, I'm just scooting over here. So now I get x squared plus 2x plus 3. That one does not factor. There's no factors of 3 that add up to 2. Factors that subtract but not add up. So I'm going to have to use quadratic formula here. So I'm just plugging in all my stuff. Okay, and then simplify. So it gets me 4, and then that's minus 12, 2. Gets me negative 8. That one factors to be 2i root 2 over 2. I can reduce. Oops. I done goofed up there. Okay, 1 plus or minus I. Okay, so these would be the solutions that I would have. Okay, now notice 1 is a real number. 2 of them are not real numbers. So I won't be able to like that is something I won't be able to graph. So keep that in mind. I'm not looking for you to be able to know what that's going to mean. But we just need to just be able to recognize that those are there. So there's not other ones to worry about. Okay. So here I'm going to graph the one I know. I know I have 2. Okay. So this one is odd because it's a cube root or cube power. And then it's positive because the leading coefficient's 1. So that means that I'm going to have start at the negative side and go up. Just so you know, that would be 0, negative 6 for my y-intercept. That is where some undulation happens, but that's because I looked at it and I saw it on the graph. So just like I said, you're not going to know that stuff just based on the sketch. So don't worry about what the sketch looks like. You're just trying to figure out where does it fit this, like make it so it's true. So here we're saying it's a less than or equal to 0. So I want it to be negative and equal to, or make it negative and 0 at the same time. So my solution here would start at 2, and I would include 2 because that is where it makes it 0. And then, did that backwards. So 2. And then because negative would be down here, I would have negative infinity or parenthesis. Okay, so then that would be my answer. Okay, so hopefully you got that as well if you tried it. Okay, so let's go to algebraically. So to solve algebraically, the steps are pretty much the same, except for step 4. So first 3 steps are exactly the same. I want everything on the same side. I want to factor, I want to find my zeros. Then step 4, I'm not graphing it. I'm going to use, this is where that intermediate value theorem kind of thing that we used a long time ago. We're going to test some values in between our zeros to help figure out if it's positive or negative, so where our graph would go, but just using a number line and then solving from that. Okay, so here, example 2a, I want to move my x over and my 4 over. So that gets me x cubed plus 4x squared minus x minus 4 less than 0. Okay. Now here it's got 4 terms, so it looks like I could group if I'd like to, which I will. So then that gets me x squared, and then x plus 4. That leaves me with, take out a negative 1, x minus, or x plus 4. So it looks like my parentheses match. So I factor out the x plus 4. Leaves me with x squared minus 1. Okay. So here I could factor this x squared minus 1. That's the difference of squares. So it gets me x minus 1, x plus 1, and then less than 0. Okay, so now this tells me that I have zeros at negative 4, 1, and negative 1. Okay, now I'm going to make a number line here. So I just have to, now here you don't have to be super exact. I don't, so you don't have to make all the tick marks if you don't want to, because this is just a sketch. So give yourself some space. Now I want to kind of test areas in between these interval or these zeros. So like you're dividing it up into sections. So there are 4 sections. So I need to know what, like, if this is positive or negative, if this area is positive or negative, if this middle area is positive or negative, or this outside to the right area is positive or negative, okay? So that's what I'm trying to determine. So I'm going to pick values in those areas to help me determine that. I don't need to do a million. Since I have 4 sections, I just need 1 from each, so just 4, okay? So this will take a little while to do, just so you're aware. So I'm going to pick negative 5. I'm going to pick negative 2. I'm going to pick 0. And I'm going to pick 2. Okay? Try to pick nice, easy numbers for yourself. The lower, the better. So let's test when x equals negative 5. So it means I plug it back into this polynomial that I've already factored. It's going to be probably easier for you to do. So negative 5 plus 4, negative 5 minus 1, negative 5 plus 1 is less than 0. So that gets me negative 1, gets me negative 6, and that gets me negative 4. Okay? That gets me negative 24. So that indeed is less than 0, so I would say that's true. I put a little plus there, and then I test, sorry, didn't spell my test right. Then I test the next number. So I said when x is equal to negative 2, so I plug that in. Okay, so negative 2 plus 4 is 2. Negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. So that gets me 6. That is not less than 0, so that would be false. Okay, I'm going to scooch this down a bit. So test the next one when x is 0. So plug that in. Get negative 1 and I get 1. So it looks like here I get negative 4. That is less than 0. So that is also true. And then I test my last one. X is equal to 2. So it gives me 6, 1, 3. So 6 times 1 times 3 gets me 18. That is not less than 0. So I would say that is false. Okay, so let's go back up here and let's plug these in. So this one was positive. Oops, my bad. Oop. It looks like I goofed up there. So that one was negative. This one is positive. This one's negative. This one's positive. Okay. So the places where they were true, that's going to be part of my solution. The places that were false did not meet the solution correctly. So I'm going to not include them in my answer. So here at the bottom, see if I can stick this in. So I would say that in between -4 and, after like less than -4 would be, so I would say less than, negative infinity to -4. Remember, it's not including the 0, so it'd be parenthesis. Then union, parenthesis, from -1 to 1, parenthesis, because then after that, it's positive, so it doesn't make it true. So then this would be my answer. Okay? Let's move on to the last example here. Okay? So if you would like to try this one on your own, pause the video now, give it a shot. Sorry that this video is pretty long, but it's kind of takes a kind of while to do. So I'll go ahead. Hopefully you stopped and tried it. Let's try orange here. So 24x is not on the correct side, so I'm going to move that over. So it gives me 6x is a third minus 10x squared minus 24x greater than or equal to 0. I want to factor. It looks like I have an x and a 2 in common, so I'm going to take that out to make the factoring later easier. That gets me 3x squared minus 5x minus 12 greater than or equal to, okay? Now, for this one, I'm going to use my little grouping trick to do the factoring. You can do it however you want, or you can use quadratic formula. It should give you some nice answers there. But here, remember that I would multiply the outside, so that gets me negative 36x squared. I want to split that into two factors that subtract to get me -5, so that'd be negative 9x plus 4x. Bring down my other numbers. Okay. And then I'm going to break this up. So then I can take out a 3x out of the first one. That gets me x minus 3. I could take a 4 out of the second 2. That gets me x minus 3. Good. I have common factors there. That leaves me with 3x plus 4. Okay. Now, those are the factors. Don't forget about your 2x that you had at the beginning. So that is your polynomial all factored out. So step 2 done. I want to find my zeros. So here, x should be 0, 3, and it looks like -4/3. Okay, so when I'm making my number line, and how about we scooch over here? So make my number line. I have 0. I have 3. And then I also have, I know it's not that far over, but I'm just going to give myself some space. So you have those areas now. So you need number to the right of 3, a number in between 0 and 3, a number in between -4/3 and 0, and a number to the left of -4/3. Okay? So for me, I'm going to pick -2. -1 actually fits in between -4/3 and 0, so that's nice. I'm going to pick 1 in between 0 and 3, and 4 to the right of 3, and -2 to the left of -4/3. So at least I have all whole numbers there. That's nice. And then I want to test. So plug in -2. Also, I guess another like nice little tidbit here. If you wanted to find, remember that synthetic substitution is a possibility to help you find these values. So if I was to start with what the polynomial had to begin with, using -2, so 6, -10, -24. Now here I'm missing the constant, so that would be like a 0 for your synthetic, just so you're aware. So 6, -12, -22, that's 44, and that's 20, that's -40, and a -40, okay? So that would be, this number is that greater than or equal to 0? That is not, so that's false. So maybe you want to use synthetic substitution. I'm just going to continue doing that because it seems pretty easy. I'm going to test. Oh, let's see, -1. Now note, I'm just doing this, like I'm using synthetic division to help me. You don't. So keep that in mind. Just because I'm doing it right here doesn't mean you have to. 6, -6, -16. 16, that's -8. 8, that's 8 there. So 8 is greater than or equal to 0, so that's true. Okay, let's scooch this down a bit. So I'm going to test x equals 1. So 1. So 6, -4, -4, -28, -28, -28. So that is not greater than or equal to 0, so that's false. Okay. So last one, I want to test. There was 4 that I picked. So 4, 6, -10, -24, 0. So 6, 24, 14. I think that's 56. 56. 32. 32. Would be 128. And then add down 128. So 128 is greater than or equal to 0. So that's true. So let's go back up here. So I got negative. Here I got a positive. Here I got a negative. Here I got a positive. So in this case, since it's greater than or equal to 0, I want all the positives. So my answer, and because it's greater than or equal to, I'm going to include these. So I'm going to use brackets. So for the interval in between -4/3 and 0, I'll have brackets, then union. Then the next one would be after 3, so include 3 to infinity. Sorry about that. Okay, and so then that would be my answer. Okay, so hopefully this is helpful. Sorry that this was so long again. Lots of steps to go through, especially with higher powers. So thanks and have a good one.